Good morning. Am I audible? Chalo bhai, so we have to start electrostatics and electric potential, right? We have to cover today only electrostatic, electric potential. Obviously, theory-wise, we can't do. I'm hoping that theory you might have gone through. So we will discuss the important question based on it. Chalo bhai, enjoying there. You guys are chilling plus taking class also. Okay. Not enjoying. चलो ठीक है स्टार्ट करते हैं. It is live in YouTube. I think it is live. Yeah, it is live. Can you open the chat?
Chat also, no message.
Okay.
No message. One check.
Everyone nahi. Okay. So let's start then. Let's start with the question number 1. Tell me the answer first. Theory we will discuss from the question only, don't worry. Theory we will discuss from the question. Okay, 3, 3, 1, A. Okay. 3, 3, 3, 3, 3. Nice. So let's see. They're saying in an electric field of a point charge Q, there is a point charge Q placed over here, bacha badi. Point charge Q placed over here. And certain charge is carried from point A, another charge is there. Let's call it Q dash. It is being carried from point A to point B, to point C, to point D and E. Then work done by electric force, means work done by the electric force produced by, due to this charge. Work done by electric force due to this charge. So you can write that work done equal to change in potential energy. And change in potential energy, if you recall, bacha, it will be K Q dash by R, or you can say R final minus K Q dash by R initial, where R final and R initial will be distance between the charges. So if you look at the distance between the charges, it was R. Now, when the Q dash will be at point B, then also the distance will be R. When Q dash will be at point C, then also distance will be same R. Every point it will be same R. So initial distance and final distance both are equal. So since R initial is equal to R final, let me remind you again, R initial and R final are distance between the charges, right? So both distances are equal. That's why here work done will be 0. In all the paths, work done will be 0. I hope you understand this. Chalo, next question then. Okay. Josita is saying 2. Let's see. 1. 2, 2, 2, 1. Okay, majority of you are saying 2. Priya is saying 1. 2. Okay. Four equal charges are placed at the four corners of a square of each side A. Work done in removing a charge minus q from its center to infinity. Let's say charge q here minus q was placed earlier, right? Minus q was placed at the center. Now we have to take it to the infinity. This minus q we want to take it till infinity. Then obviously these forces will do some work, right? These forces will do some work, or you can say the external force which is removing it will do some work. So when we talk about the external force, so we say delta U, and when we talk about work done by electric force, we say minus delta U. Hai. So let's calculate any one of them. So if I ask, if they are asking about external force work done, then we will write final minus initial. Now, while writing potential energy, we will not write potential energy due to the interaction between Q and Q, Q and Q, Q and Q. No, we will not write potential energy due to interaction among the charges, among the positive charges, because the potential energy due to Q and Q, when minus Q was here, then interaction between Q and Q, and when this minus Q will be here, then also the potential energy of Q and Q will remain same. So when you will subtract, it will get cancelled out. So we will not consider the potential energy due to the interaction between all plus Q. Okay? Understand the theory here? We will only consider the interaction between Q minus Q, Q minus Q, Q minus Q, Q minus Q, due to four charges. Okay? So what is the potential energy? Initial we will write better. Initial we will write, if you look at this distance, it is minus kq square divided by L by root 2 into 4. It will become 4 root 2 minus 4 root 2 kq square by L. What is final? When the minus q is at infinity, then potential energy will become 0. So if you do final minus initial over here, final minus initial, so you will get 4 root 2 kq square by L. 4 root 2 kq square by L. I hope you understand the theory here. Why we are not writing complete potential energy? है ना? Because if you remember anything like this, कि sir, the potential energy formula is n into n minus 1 by 2, then 5 particles are there, then the number of pairs should be 5 into 4, 20 by 2, 10. So you should write sir 10 pairs, है ना? You are writing only 4 pairs out of 10 pairs. You are writing only 4 pairs because I'm interested in only potential energy of this minus q. Means due to only this one, not due to all the charges. We are not interested in potential energy of q and q. This q and q means all the positive charges potential energy we are not bothered. Why? Because it will remain same. So if you want, you can write all 10 potential energy final, 10 potential energy initial, but out of 10, 6 will get cancelled out. Hana? So only you have to write 4 terms of potential energy, which we have written over here. Okay. ठीक है. कितना आंसर है? 4√2 kq square by L. Okay, so we got 4√2 kq. K we will write 1 by 4 pi epsilon naught q square by L. So it's coming out to be root 2 this one. Option number 3 is coming. ठीक है, आगे चले. I hope you learned the theory from this question. This is alpha particle. Okay, some people are saying 1, 4, 1, first option. Satakshi is saying first option. Tarun is saying 1. Rohit also 1. Okay, so almost everyone is saying 1. Okay, ठीक है. So alpha particle is going from 70 volt to 50 volt. Then how much kinetic energy will be gained? So the gain in kinetic energy will be loss of potential energy. Because the mechanical energy will remain conserved, so gain in kinetic energy will be equal to loss of potential energy. Loss of potential energy we can simply write Q delta V. Q delta V. How much is Q? Charge of alpha particle is 2e. And delta V, 70 and 50. So 70 minus 50. So it becomes 40 eV. First option is correct. 40 electron volt. Next. Okay, option 2. Annapurna is saying option 2, Preeti saying 1. Okay, a lot of answers coming. 2, 2, 2, 4, 2, 4, 2, 2, 2. Okay, so lot of you are saying 2, some of you, very few of saying 4. That means there is no doubt in 1 and 3. 1 and 3, everyone is saying wrong. Only 2 and 4. Okay, let's see then. 10 electrons are equally spaced and fixed around a circle of radius r. Relative to V equal to 0 at infinity, the electrostatic potential and the field at the center CR. If equal charges are placed bacha, at equal distance, है ना, 10 charges, 3, 4, 5, 6, 7, 8, 9, some, है ना, 10. Equal distance, then we know they will cancel each other, right? Because the field will be also formed at equal angle. Like this, field will be formed at equal angle, है ना? So when field, when n number of vectors of equal magnitude, listen to me, when n number of vectors of equal magnitude are inclined at equal angle, then the resultant is always 0. Huh? N number of vectors, let's say 6 vectors inclined at equal angle, 2 pi by 6, that is pi by 3, that is 60 degree. So equal number of vectors inclined at equal angle, then their resultant is 0, provided the magnitude is also same. Okay, then their net resultant will be 0. That's why net field will be 0. So 2 and 3 should be the option. But if you consider the potential is simple addition, which is n kq by r. Potential will be simple n kq by r. Okay? Because potential is not a vector quantity. It will simply follow scalar addition. And all potential due to electrons will be negative only. Okay? This is a very simple question. I hope you understand. Option number 2 is correct. Potential is non-zero, but the electric field is 0. Okay. Option 3, 1, 2, 1, 1, 3, 3. Okay, so we are getting a lot of options by lot of different options. 1, 2, 3, 1, 2, 3. Okay, no one is saying 4. Let's see. Okay, 3. Okay. They're asking ki where the electric potential is 0. Where the electric potential is 0 and where they want a point P on the line joining the charges. Okay. So this is 12 microcoulomb. This one is minus 6 microcoulomb. There will be how many zero potential point? I hope you remember there will be 2 zero potential point. One will be here, bacha, है between, and another one will be somewhere here. So let's say this distance is x. This distance is x. Okay? And another one will be between also. So there will be 2 on this line. There will be 2 zero potential point. Okay. So if they are asking this one, so what we will write? Due to 6, we will write key. We will simply write V1 plus V2 is equal to 0. So due to 12, it will be K Q by distance will be, this one is given how much? 20 centimeter. So it will become 20 plus X. We have taken distance of the point from -6 because they are asking distance of P from -6 only. Okay. So minus, because potential due to -6 will be negative, equal to 0. So if you cross multiply, we will get, I think, 2x equal to 20 plus x. So x equal to 10 centimeter, which is 0.1 meter. So first option seems correct. Direct formula also we can use. चले आगे. Next question, question number 6. Okay, so we have covered different variations of electric potential. Now let's move toward, this is dipole. Okay. This is not 1, this is L. This is L, not 1. Electric charges QQ minus 2Q are placed at the corners of an equilateral triangle ABC of side length L. The magnitude of electric dipole moment of the system is, okay. Okay, one thing they have not mentioned here. They should have mentioned, placed at the corners of an equilateral triangle. Where this minus 2Q is placed, है ना? That will decide. अच्छा, equilateral बोला. I thought, okay. No, then it is correct. I thought they are saying right angle triangle. Okay, so no problem. This one is Q. This is minus 2Q, which will break as minus Q and minus Q. Now, you can see now this minus Q and minus Q has a dipole moment Q into L. This minus Q and Q has a dipole moment Q into L. So there are two dipole moments, one like this, another one here. Angle between them is 60 degree because they are tail to tail joined. We can claim the angle is 60 degree. So the resultant will be in between them, and it has a magnitude. This one is QL. So 60 degree, then that means it will become √3 QL. Option number 3 is correct. Take the resultant of QL and QL. Angle between them is 60 degree. You can use 2a cos theta by 2. Or you can use under root a square plus b square plus 2ab cos theta. That much vector addition we can do, right? Chalo. First, question number 7. This is a theory. I hope you remember the result. Option 4. Fourth option, 4. Good. All are correct because option 4 is correct. A point Q lies on the perpendicular bisector of an electric dipole of dipole moment P if the distance of Q from the dipole is R, much larger than the size of dipole, means we are talking about short dipole, then electric field at Q. We are placed by perpendicular bisector, equatorial point. So we have a formula Kp by RQ, it means E is proportional to P and E is inversely proportional to RQ. So fourth option is correct. Is there any diagram, Rukja? Okay, diagram is here. What we can do? Okay, first you go through the question. Consider a system of three charges placed at point A, B, and C. Take O to be the center. Angle CAB 60 degree. Choose the incorrect option. Okay, so the electric field at point O is directed along the negative x-axis. The potential energy of the system is zero. The potential. Leave this question because this is incomplete also. Leave this question. Question number 9. I think it was asked in JEE mains also. This is JEE mains CYQ. Solve question number 9, beta. Option number 2, okay. Two. Okay, a lot of answers are coming. All are saying 2. One answer came 3. Okay, 2. Two equally charged identical metal spheres repel each other with the force F. Distance r between them. A third identical but uncharged C is brought in contact with A and then placed at the midpoint of the line joining A and B. The magnitude of net force on C. देखते हैं. Two charges were placed, let's say Q and Q. Force was F, so force was proportional to, we can say, Q square. Then we bring a third charge and it is brought in contact with A. So if you bring in contact with A identical, so the charge will now become here Q by 2. This one will be also be now Q by 2. And then placed at the midpoint of the line joining A and B. Okay. So net force on C will be, this B will repel it and A will also repel it. So net force will be FB minus FA, which is proportional to, I think, it is Q square by, we have to write complete, K Q square by 2 divided by R square by 4 minus K Q by 2 into Q by 2 will be KQ square by 4 and distance between them is R by 2, so it will become R square by 4. Let's do the calculation. It will be 2 KQ square by R square. It is coming 1. I think it is coming 1. Please check the answer or let me know if I am doing any mistake. We can share PDF at the end, no problem. But look at the solution. Is it coming 1? Okay, 1. Okay then. ठीक है. Again, let me tell you, here the force was kq square by r square. Here the force was kq square by r square. When you bring a third charge q and touch it here, so they will have average charge means q1 plus q2 by 2. So c was having 0 charge, a was having q charge, then it will become q by 2 and q by 2. So a is having q by 2, this one is also having q by 2. So net force on c will be repulsion by B and the repulsion by A, repulsion by B, and the distance becomes R by 2 now. This complete distance is R, now it becomes R by 2. So we can write KQ into Q by 2, KQ square by 2 divided by R by 2 whole square, minus, opposite direction minus, KQ by 2 into Q by 2, which is KQ square by 4 by R by 2 whole square. 4 will go in numerator, right? 2 and 4 cancel, 2 times आएगा, 4 cancel. Yes, it is correct, I think. चलो then next question चलते हैं. This point we already discussed in that circle wala question. Can we go fast? Question number 10 without wasting any time? Okay, lot of answers are there. 4, 3, 4, 3. Why 3 options you guys are saying? Equilateral triangle charges are placed at corner, the electric intensity at center. Oh, electric field we are asking, na beta. So I have to do vector addition, na? You can't do scalar addition. I'm not asking potential, we are asking electric field. And as I told you, electric field is a vector quantity. So due to this Q, electric field will be away from, due to A, it will be like this, due to C, it will be like this. And since charges are equal, Q, 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 distances are also equal, R, R, R. So that means the magnitude of EB, EC, all 3 magnitude are equal. Direction different, but magnitude equal. So what I said, equal number of vectors inclined, n number of vectors inclined at equal angle and they are having same magnitude, then net resultant is 0. So answer will be 0, fourth option. If the charges are different, then obviously you have to calculate. Next. Question number 11. Okay. Option 4, 2, 3, 3, 2, 4. Electric dipole is placed in uniform electric field. Okay. The dipole will experience. Now, since it's a uniform electric field, now you recall the theory better. Since it's a uniform electric field, then net force on the dipole will be always 0. Whatever is the orientation, net force on the dipole will be always 0. And the torque we say P cross E. So torque may be 0, may not be 0. Okay? But force is always 0. So if they are saying a force that will displace it in the direction of the field, wrong. There will be no force. A force that will displace it in a direction opposite to the field, again it is wrong, because there will be no force. Dipole will not be displaced in any direction, same direction or opposite direction. A torque which will rotate it without displacement, partially correct. A torque which will rotate it and force that will displace it. This one is wrong because again there will be no force which are going to displace it. So best possible option is, it is option number 3. ठीक है. हाँ, I know कि torque may be there, may not be there, but I think the best option is 3 only, because option number 1, 2 and 4 they are saying कि force must be there, which is completely wrong. 3 can be correct. Okay, and most of the time 3 will be correct only, because torque will be 0 only at theta equal to 0 degree and 180 degree. Remaining cases torque will be there, right? Question number 12. Okay, option 2 you are saying. You want to see the remaining option also? The remaining options are root 5 and 20. The remaining options are root 5 and 20. Please keep it in mind. Root 5 and 20. If you want, I can write it here. Third option is root 5. Fourth option is 20. Harika is saying 4. Okay, 1. 4, 4, 1. ठीक है. Option 4. चलो देखते हैं. An uniform electric field exists along positive x-axis. The work done in moving a charge 0.5 coulomb through a distance 2 meter along a direction make an angle 60 degree with the x-axis. Okay. Electric field is along x-axis. Displacement is along 60 degree from positive x-axis. Magnitude of electric field they are asking, and they are saying what they are saying. Okay, the work done. So force acting will be QE into displacement into cos theta. Now work done given is 10, charge given is 0.5, electric field they are asking, displacement is 2 meter, cos theta, cos 60 is half and 2 cancel. E will be 10 divided by 0.5, which is 20 volt per meter. Option 4 is correct. Next question. Which of the following graph represent the variation of electric field from center of a charged spherical conductor and field or potential? Electric field due to a spherical conductor. So now when you give charge on the conductor, it is spread on the only outer surface. So you don't ask, sir, a hollow sphere or solid sphere, they have not mentioned, they have only mentioned a sphere because it is a conductor. So if they say conductor beta and if you give charge on the conductor, then it will spread only on the outer surface. So we will not see where the mass is present. We will always see where the charge is present, and charge is present only on the outer surface, only on the outer surface. That's why we will use the result of hollow sphere. We will use the result of hollow sphere because whatever charge you will give, it will spread only on outer surface. So if you look at the charge, it will form a hollow sphere. Okay? Now inside hollow sphere, everybody knows the field is 0 and outside it is kq by r square. Inside 0 and outside kq by r square. So let's check all the options. First one, not 0, it's constant, not 0, potential, if they ask potential, this one will be correct. But field, it is wrong. Again, solid sphere, if it is there, solid sphere non-conducting, okay. Third one, you can check, it is 0, and then it is 1 by r square, hyperbola. Option number 3 is correct. A hollow cylinder has a charge q within it. If phi is the electric flux associated with the curved surface B, then flux lead. ठीक है. Let me explain the question. There is a charge q placed here at the center, and through the curved surface, flux is phi. Then they're asking what is the flux through the plane surface? What will flux through the plane surface? Charge q is inside. Flux through curved surface is phi. They're asking what is the flux through plane surface A. Fourth option, good. Okay, I think this is need PYQ, right? Fourth option, fourth option, fourth option. चलो. Okay, बच्चा देखो. The net flux will be q by epsilon naught. Net flux will be phi A plus phi B plus phi C equal to q by epsilon naught. They are asking what is phi A. Phi B through the curved surface B, it is phi only. Okay? And since charge is placed symmetrically, so don't you think the number of field lines which will be crossing A and the number of field lines which will be crossing C will be equal? Right? Because it is placed at the center. So the flux through A and flux through C will be equal. So phi A and phi C are equal. So we will write 2 phi A plus phi B, and but phi B they are writing phi only, है ना? Equal to q by epsilon naught. So phi A we will write q by epsilon naught minus phi, q by epsilon naught minus phi, and then we will multiply here half. Question number 15. Question number 15. Everybody knows this. Come on, this is a simple theory, beta. This is a simple theory, right? Yes, at axial point, this is a dipole, this is axial point. So here field, for First of all, direction is parallel to dipole. So it is 2 kp by r cube. Axial point. Equatorial point is kp by r cube. If r is same, like they have said, same distance. If r is same, then you can say the axial field is 2 times of equatorial field. So option number 2. Question number 16. Option 4. Okay. ठीक है, तो they are saying Q1, Q2 and Q3 are in the order, are placed equally spaced along a straight line. So are they saying better like this? This is Q1. Q2 and Q3 are equal in magnitude but opposite in sign. Okay. Okay. So let's say this is minus Q and let's say this is Q. Q3 is Q and Q2 is minus Q. Now net force on Q3 is 0. Here the net force is 0. So who will apply force better? Due to minus Q, it will be, if you consider this distance L, this one also L, and then due to Q1, the force will be like this. So we can write magnitude wise KQ square by L, the force between these two, and here we can write KQ Q1 by L square, sorry, by 4L square. So Q1 we are getting 4 times Q. Q1 we are getting 4 times Q. And Q is nothing but Q3. So option number 1 is correct. You guys were saying option number 4. Wrong. Don't remember any result thinking this is the same question. ठीक है? Question number 17. Electric charge is uniformly distributed along a long straight wire of radius 1 mm. The charge per centimeter length of the wire is Q on other cylindrical surface of 50 centimeter and length 1 meter. Okay, let's see the diagram. Diagram not given, that means we have to visualize. Tell me how much total flux will pass through the cylindrical surface. Let me help you with the diagram. Charge per centimeter, another cylindrical surface of radius 50 centimeter and length 1 meter. Okay. This length is better 1 meter and wire is inside the cylinder. This 50 centimeter, this 1 mm is it is of no use. Only this length is 1 meter, and charge per unit length is q coulomb per centimeter. Q coulomb per centimeter. So 1 centimeter has q coulomb. Then 1 meter means 100 centimeter. So 100 centimeter will have 100 q coulomb. So charge enclosed here inside the cylinder will be 100 q. Because 1 centimeter has q coulomb, then 1 meter, which is 100 centimeter, will have 100 q coulomb. So the total electric flux passing through the cylindrical surface will be 100 q divided by epsilon naught. It will be 100 q, but it is 1 mm. How better? It simply means 1 mm means what? Its radius is 1 mm. This radius is 1 mm and cylinder is 50 centimeter. It is just saying the complete wire is inside the cylinder. Radius wise, this thickness wise, the complete wire is inside the cylinder. That is what they are saying. देखो, this wire has a radius 1 mm, which is very low, which is very less, and the cylinder has a radius 50 centimeter. So it means, here see, the radius is 50 centimeter and wire radius 1 mm. So understand, this is 50 centimeter. Here it is only 1 mm. So it just signifies the complete wire is inside cylinder. Okay? This is the meaning. Now, but cylinder length is 1 meter. Cylinder length is 1 meter. The length of the cylinder is 1 meter like this. So they are asking how much flux. Okay? So don't worry about these data, 1 mm, if it is 2 mm or 5 mm or 10 mm. If this data is less than 50 centimeter, we don't have any problem. Because it simply means the wire, the infinite wire is inside the cylinder. Okay, so we have to consider all the charges. This is the meaning. Now, total flux through the cylinder will be equal to charge enclosed according to Gauss law. Charge enclosed by epsilon naught. Now, charge is everywhere. This is the infinite wire, let's say. So the charge is everywhere. But we are not bothered about all the charges. We are only considering the charge which is enclosed by the cylinder of length 1 meter. Now, what they are saying? They are saying it has q coulomb charge per centimeter. 1 centimeter of the wire. 1 centimeter of the wire has q coulomb charge. Then we are interested in 100 centimeter length. This much of wire will have how much charge? So 100 q. 1 centimeter q. So 100 centimeter, 100 q divided by epsilon naught is the answer. Second option is correct. Question number 18. They're saying the time period of a pendulum is t naught, but when the plates are charged, the time period changes to t. So simply they are saying find the ratio of t and t naught. Means without electric field and with electric field. Simple thing, without electric field and with electric field. Electric field, without electric field it is t naught, with electric field it is t. Find the ratio, come on. Less number of answers we are getting. Option number 4. Okay. Option number 4. Come on, yaar. 1, 3, 1. Confusion is between 1 and 3, I think. Ashish, okay. Dhoni sahab. Harika is saying 3. Aksha, okay, okay. ठीक है, so we know that time period of simple pendulum is better 2 pi under root L by G effective, so we can say T is inversely proportional to root of G effective. So in case of T naught, है ना, the G effective was G, but in case of T it's a positive charge, है ना, then electric field will be positive to negative, so force QE will be also downward, mg will be also downward, so G effective will be in this case will be G plus QE by m, है ना, the electric force and mg are in same direction, so G effective will be mg plus QE divided by m, so it will become G plus QE by m, but inversely proportional beta, so they are asking T by T naught. T by T naught will be root. Invert करेंगे बच्चा, like we will say here we will put T naught corresponding to T naught, and here we will put G plus. So option number 1 is correct. Option number 1 is correct. I hope you understand this. Option number 3. Achha, sorry, my mistake. Option number 3 is correct. I didn't say. Yes, option number 3. I hope you learned the concept of G effective. When mg and QE are in same direction, we will take G plus A. If QE, let's say they take a negative charge, then QE will be up. Although electric field will be down, but the QE will be up. Don't see electric field, see the force. So if the charge is negative, then although the field is down, electric force will be up, then you will take G minus QE by M. And in some question, they will say ki electric field in the right direction. Forget the plate. Electric field right direction, then it will be QE here. So mg down, QE right. So we will take G effective to be under root G square plus QE by M whole square. 3 cases they can ask you. Hana? 3 cases they can ask you, okay? mg QE same direction, mg QE opposite direction, mg QE perpendicular direction. Why not 3? Why not 1? नहीं बेटा उल्टा है ना, they are asking T by T naught. That's why T by T naught. If they are asking T naught by T, then we will say option number 1. Question number 19. I think they should say electric field of maximum torque, they should say. Maximum torque acting on the dipole. Because angle is also important, no? So torque will be P, sine theta, but maximum then P. So it will become Q into L. Dipole moment is Q into L. Q is how much, beta? 2 into 10 power minus 6. L is 3 centimeter. Electric field is 2 into 10 power 5. So 2 into 10 power 5. So this will become minus 1 then. It becomes 12 into 10 power minus 3. 12 into 10 power minus 3. But yeah, it's already mentioned maximum torque. Because if they don't mention maximum torque, then option number 4 will be also correct. Because anything less than 12 into 10 power minus 3 is correct. ठीक है? Next. Gauss law. Okay, option number 2. Charge contained in a sphere of radius A. देख भाई, let's say this is sphere of radius A. If you want to find a charge contained here, then we should find flux through it. And luckily, we have been provided that electric field is acting radially outward. So everywhere electric field is acting like this, radially outward. And if you take area vector, so area vector will be also radially outward. So at every point, E and dA vector are parallel. So if every point E and dN vector are parallel, the flux we can write E into A into cos 0 because E and D are parallel. So E is given A into R. Area we will write 4 pi R square, complete surface area, right? Cos 0 is 1. So this is flux, but flux is Q enclosed divided by epsilon naught. So Q enclosed will become 4 pi epsilon naught AR cube. 4 pi epsilon naught AR cube. Putting the value of R equal to A, we will get this option number 2. Because net flux through this sphere, it will be dependent on the charge enclosed. Net flux through the sphere will be dependent on how much charge is inside this sphere, right? And they're asking the same thing. How much is charge is contained inside the sphere. Next question. Question number 21. To know the charge is positive or negative, you have to look here, the arrow. If you see the arrow here, bacha, so it is going away, like originating from this charge. These are originating from A and terminating at B. You can see the arrow. The field lines are terminating at B, originating from A, so that makes it positive charge and that makes it negative charge. Okay? So option 1 is correct. You don't have to see anything else. Option 1 is correct because only one option is saying A is positive and B is negative. But if you want to check whose magnitude is more, then you have to count the number of field lines. So if you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines are associated with A. If you count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Less number of field lines are there, right? So it means if someone asks you how much is the QA by QB ratio, then you should say 12 by 10, which is 6 by 5. 12 by 10, which is equal to 6 by 5. Twenty-two is a good question. Please try to solve. Okay, option number 2, 4, 3, 1, 1, 3, 2. All options we are getting. All options we are getting. चलो भाई देखते हैं. The most important word here is this one. Point charges 4q minus q, 4q are kept on the x-axis. I will teach what time you will teach. I will teach till you clear your NEET exam. If you clear next year, then I will teach till next year. Chalo. Point charges plus q minus q and plus 4q are kept on the x-axis. Understand better? 4q, 4q, and minus q, they are kept x equal to 0. Okay. This is x equal to 0, bacha. This is x equal to 2a. This is x equal to a. It is minus q. It is minus q. Okay. Now they are saying all are kept. These two are kept. They are not saying these two are fixed. If they say these two are fixed, so obviously if 4q and 4q are fixed, then you can't talk about the equilibrium. Because they are fixed only. So you can't say stable or unstable because you can't displace them. Okay? In that case, they talk about minus q, which we can discuss. But here, all are kept. That means all are at equilibrium. But the moment you displace any one of them, the moment you displace any one of them, what will happen? Then they will not be at the same place. Like if you displace minus q here, now net force on this 4q will not be 0. So they will get displaced and the net force will not be 0 and they will not come back to the same position again. So this position is there, but it is at equilibrium only at this instant. The moment you displace any one of the 3 charge, the entire equilibrium will be disturbed forever, and this arrangement we will not get back. That means all are in unstable equilibrium because these charges are kept. Okay, so option number 3 is correct. Some of the electric field lines corresponding to an electric field, the figure suggests that. Let's discuss the diagram. Okay, one of the easy question. Everybody knows this, right? they're asking field, so we have to know the magnitude of field, we have to look at the density. Here the field line separation is same as C, so that gives us EA equal to EC, and here the field lines are far, so here magnitude is less, here magnitude is less. ठीक है, so third option is correct. 24. Yeah, due to that two factor, we say more in case of axis of dipole. Due to that two factor. This is a null point question. I hope you remember the result. 24 का 4 होगा, 24 4, 25. Direct formula we remember. Okay, so we have not mentioned from which charge. Where should the third charge? Let's find the distance from कहाँ से find करेंगे? Let's find the distance from Q only. Let's find where it will be. Where this charge will be better. The third charge, where it should be placed. Left, middle, or right? Come on, tell me the answer of this one only. Left, middle, or right? Left, 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 middle, left, left, left. Yes, it should be placed in left. Why? Because these are different charges, right? Opposite nature. So null point will not get in between. Null point will get outside, and this side, at the side having lesser magnitude. So Q is having less magnitude as minus 3Q. So it will be this side. And what is the formula? If I measure the distance from this Q, then I hope you remember the formula of the null point, which is root Q into D, root Q into D divided by bigger minus smaller, which is root 3Q minus root Q. So it comes out to be D divided by root 3 minus 1. D divided by root 3 minus 1. This is the answer. But you will not find any answer like this. So we have to personalize it. See here. What we will do, we will multiply root 3 plus 1 and divide with root 3 plus 1. Now when you multiply root 3 minus 1 and root 3 plus 1, you will get 3 minus 1. A plus b, a minus b, a square minus b square, which will be 3 minus 1, which is 2. So we'll get d into root 3 plus 1 by 2. Second option is correct. Okay, so we'll keep our discussion till here, Bachawadi. Next class will be of capacitance, current, electricity. Please come prepared because I will discuss questions, more questions. Okay, because if I ask you any topic you want, because in one lecture there are capacitor and current, electricity, obviously we cannot discuss all the things, right? So if I ask you one topic, two topics, then you will one by one you will tell the entire chapter. ठीक है, so that is not possible. QR code नहीं बेटा, इसमें QR code नहीं आएगा ना. This we are not discussing on the note, right? So ठीक है, so after that we will discuss. Please come prepared ना for the capacitor and current electricity. ठीक है, PDF okay हो जाएगा. चलो टाटा, bye bye, thank you.